A vector with initial point at the origin is called a position vector. And a position vector with endpoint at the point AB is going to be written in this form. And so we've already seen one. It might have been 6, 8. And that just means that that vector ends or terminates at 6, 8. They're going to ask you some questions about horizontal and vertical components. Just understand that when they talk about horizontal components, they're talking about the x number. And when they talk about vertical components, they're talking about the y number. That's going to be big. Also, when you end up having to find angle theta, it's going to have to be a positive number. There's going to be a calculator question where your answer comes out of the calculator and it's going to be a negative angle. But just understand you're going to have to think about where that is on the plane and make it a positive angle based on what quadrant it's in. Magnitude and direction angle of a vector. We're talking about a vector u, and if we want to calculate the magnitude or the size, it's going to be given by this formula. Magnitude of u equals square root of a squared plus b squared. Now that's supposed to look like Pythagorean theorem, and that's what we're doing. We're basically finding the length of the hypotenuse. Direction angle theta is going to satisfy the formula tangent theta equals b over a. So notice your AB points are like x and y. So really we already know both of these formulas. If you think back to chapter 5, we had tangent theta equals y over x, and that's exactly what this is. Tangent theta equals b over a is the same thing as tangent theta equals y over x. We've already done that. We've already used both of these formulas. So these are formulas for finding magnitude and direction of a vector. Example 1 says find the magnitude and direction for this vector 3, -2. I think we probably need to draw it. Let's draw it and look at what it is. The point 3, -2 takes us right here. So look at the vector. The vector is going to take us in that direction up until that point. Let's make that into a right triangle and do what we've done so many times this semester. I know this side is 3 and this side is 2. I'm going to call it -2 just to keep track of my signs. But in order to find the magnitude, I'm going to use this formula. Magnitude u equals square root of, got 3 squared plus -2 squared. Magnitude u equals square root of 9 plus 4, or square root of 13. So my magnitude, or my size of the vector, the length of that vector, is the square root of 13, and that's about 3.6 or so, I don't know. So we have to find the magnitude and the direction angle. We can pretty easily, using SOHCAHTOA, find that angle theta right there. We know tangent theta equals y over x. So we've got tangent theta equals -2/3. And in order to solve that, we're going to do an inverse tangent and use our calculator. Inverse tangent, -2/3. Gives us kind of a weird result, the -33.7. Okay, now remember, you might remember back from a slide before that we're not allowed to have a negative angle. That answer has to be a positive. So this should kind of make you think, hey, maybe something's not right. But just remember, that's a reference angle. Really what that means is 33.7 where tangent is negative. But that's okay because we're in quadrant 4, and that's one of the places where tangent is negative. It's a 33.7 degree reference angle in that 4th quadrant. And so think about what we've done so many times before. In order to find that angle in the 4th quadrant, we're going to take 360 minus that reference, 33.7. 360 minus 33.7 is 326.3. theta equals 326.3 degrees. So now we have a vector with magnitude square root of 13 and direction angle 326.3 degrees.